In this last example, they ask us which points on the graph of y equals 4 minus x squared are closest to the point 0, 2. Well, this is a cool problem. So we're actually minimizing the distance between a fixed point in the plane and points on a graph of a quadratic. So we've got an inverted parabola, and there are two particular points on the parabola that have the shortest possible distance to this one, 0, 2, and we've been tasked with finding out what they are. So let's sketch a quick picture so we can have in mind what we're... Okay, so here we have a sketch of a parabola that is inverted, and it has a y-intercept of 4. We've sketched this point 0, 2, and that indicates our fixed point. And then we have this point x, y, which can be anywhere on our parabola, and it's going to have a mirror image also on the other side, negative x comma y, that will also have the same distance. So if we can find x, y, we're going to have that companion point, negative x, y also. So let's just sketch in that distance that we're looking for, maybe as a dashed line. And so this is negative x, y. All right, so we're minimizing the distance between these two. My equation is y equals 4 minus x squared. We want to minimize the distance to 0, 2. So the distance formula, d of x is equal to the square root of x, the point on my parabola that is unknown, minus 0, the x value of my fixed point squared, plus, and now I need to take y and subtract 2 from it. But I want this in terms of x. Well, remember that y is equal to 4 minus x squared. So let me do this. Instead of saying y minus 2, let me put 4 minus x squared in and subtract 2 from that. So this gives us the square root of x squared plus, and 4 minus 2 is 2 minus x squared squared. And let's go ahead and expand that binomial. We get x squared plus 4 minus 4x squared plus x to the 4th, just squaring a binomial. And now we can combine like terms, and we get x to the 4th minus 3x squared plus 4. Now, at this point, I could take the derivative of this because that is my distance formula, but here's my question. If I differentiate a square root and set it equal to 0 and find critical value so that we make the square root as small as possible, wouldn't that be the same as making the radicand, which is under the square root, as small as possible? In other words, the smaller the number I'm taking the square root of, the smaller the square root. So we can save ourselves a headache in terms of differentiating by just simply renaming the radicand g of x. And so g of x is x to the 4th minus 3x squared plus 4. So I guess what I'm arguing for here is this. It is sufficient to minimize the radicand. So if we make this as small as possible, then the square root will certainly be as small as possible. So this is a lot easier to take the derivative of. So let's do that. G prime of x is equal to 4x cubed minus 2 times 3 is 6x. Set that equal to 0. We can factor out a 2x, and that's going to leave us with 2x squared minus 3 equals 0. We have critical values now of x equals 0 and x equals the square root of 3/2, and those are plus or minus. We have 2 of them. And with 3 different critical values, I'm not sure which one is going to give me the minimum distance. What can we do? Well, let's make a sign chart. All right, now we've got a sign chart for g prime of x with our critical values for g prime, and we can plug these into our calculator and get a decimal approximation, and then just pick some test values that are on each of the 4 intervals and substitute them into g prime, and then just check and see what is the sign. Is it positive or negative? So going through that process, we get negative on this interval, positive, negative, and positive. Now, as far as g is concerned, that means that the function is decreasing, increasing, decreasing, increasing. Now here I'm going from decreasing to increasing, and that means that negative square root of 3/2 is a minimum. Again, here I'm going from decreasing to increasing, so square root of 3/2 is a minimum. Now at this point 0, I'm going from increasing to decreasing, so that's a maximum. So if we picked 0, 4, that would actually give the greatest possible distance of a point on the parabola to 0, 2. So these are the 2 points that we're going to be needing to use. So let's see if we can find out what the corresponding y values are. We will do f of negative square root of 3/2, and that's going to give us 5/2, and that's actually also the same as f of positive square root of 3/2. And so the 2 points that are going to have the smallest possible distance to the point 0, 2 are negative square root of 3/2 comma 5/2, and positive square root of 3/2 comma 5/2. And our solution set of ordered pairs will be our answer.